Hi, in this tutorial I am going to introduce you a new module, the mixing tank generator. It is basically a tool with which you can create the mixing tank geometries automatically with a bunch of preset impeller types. So the first thing we need to do is create the mixing tank without the impeller. I will hit the preview so you can look what the end result might look like. So the mixing tank geometry consists of the shell. It's basically a cylindrical shape with different types of heads. Even uh, when these geometries are at the bottom, they are called head types. So you can enter your values here. Let me disable the baffles for a second. And there are different options, like the conical one. You can input the diameter of this, the cylindrical height, which is the cylindrical section here, the conical height, that is the height of this section, and the angle. Okay, and the angle would be the slope of this. So you can change that to, I don't know, 45. It will create this one. So revert back. Let's change the cylindrical height maybe to 500. So then we have the spherical ones. You can input the crown radius, that is the larger radius. The knuckle radius is the smaller one over here. You have 4 buttons for shapes that are used in industry. Like when I hit this one, it will change the crown radius and the knuckle radius accordingly to the dimensions I input here. So hit preview and you will see how it changed. The hemispherical is a easy one. Like this section is half sphere. The simple flange is a flat tank with a fillet around the section area, so you can enter different values. So if you want to introduce baffles, now you might have 3 baffles, 4 baffles. You might need to want to change the baffle width, which is the length of the baffles towards the geometry inwards. You might want to change the thickness. Let's make it thicker, and you will see that it gets thicker. The wall clearance might be 0 for completed attachment, like this. Or you might want to introduce a little gap. Normally in real tanks you will see that they are mounted here. So in CFD we normally don't want to use small geometrical features. So if you need these connection to the baffle to the tank, you might need to tweak the geometry later on. So let us revert that to 4 and maybe 0 clearance. And let us investigate what type of impellers we can use. So the first thing is the shaft. Obviously you can change the shaft diameter. You can extend the shaft to the bottom. Then it will look like this. And let us investigate the list. Well, the Russian turbine is this one. 6 blades on a disc. You can change the dimensions. You can input an angle. You can input mathematical expressions. It depends on which direction you want to rotate this one. And you can also, for some of the impellers, I have a button for standard presets. So it will dimension your geometry according to what's in literature called like standard. If you have a diameter of 1000, for example, the impeller diameter will be 1/3 of that. Okay, if I hit like 100, hit this, and if I hit preset, it looks like this. So you need to be careful because each entity is created for itself, and you might get ugly looking impellers if you tweak one value that does not match the other values. So the pitch blade turbine, hit OK, looks like this. You might want to change the blade number to 6, or you might want to change the height to something like this. It's up to you. Some of the impellers have like a hub where the impeller blades are mounted on. So if I increase the value of the hub diameter, you will see how it changes. Obviously, you would not mount like that, you would increase the hub height equivalently, I don't know, like 80, like this, or even more. So apply presets. Flat blade turbine is basically this one. You could basically mimic that with pitch angle of 0, I guess, for see. So the smooth turbine is like a pedal or backswept. It has the form of the letter C with a finite thickness. It is mounted on a disc, so you can tweak the geometries. On some of the impellers you have this checkbox where you can reverse the direction. Curved blade turbine. If you look from the top, you see this shape. You can reverse the direction. The next one is the anchor impeller. Maybe I should remove the baffles for a second. This one is used for high viscous fluids. You can change the number of blades. You can basically play around with these. Next one in the list is the plate impeller. It looks like this. You can tweak everything, every dimension. You might want to use this as a baseline to export, and then you can change the geometry on the fly. Some have here open windows, and it is then called something like gate impeller. So this can act as a template. The helical ribbon, like this. The bioprop impeller. And there are also different kinds of impellers, like hydrofoil impellers, which are more difficult to parameterize. I think it is possible, but right now I did not include these. You might need to draw these by yourself. So you can also create multiple impellers on the same shaft. Like this maybe. You can actually draw as many as you want. Right? You can like this one. Then you will need to remove the baffles, obviously. And there are also ones that can look like this. It's up to you. Now, once you created this shape, you want to use that in the cut section. So I will hit export, and it will be created down here. Let me make that transparent. So here's the shaft. We actually create full shaft down. Yeah. The shaft needs to extend it for the anchor. So even if we did not put that here, and it is also not stick through to the bottom of the tank. So impeller 1, impeller 2, anchor impeller, helical impeller. Now if you hit on this geometry, or you see it also in the object tree, you have two cubes with different colors. That means you have a compound. You can read it also in the left bottom corner here. Compound consists of, it's just a group of different shapes merged into something that is called compound, basically. If you investigate the shape, you will see the topmost shapes are 4 solids, 4 shells, 18 faces. So it's one compound and 4 solids. What I want to do is I will box select, but before I will enable the solid selection, and then I will hit on this icon right top corner to extract these. So once I extract it, I can combine these into one shape, into one solid geometry. Here is the fuse operation. I will box select these. I will hit this, and you will see selected 4. I will hit unify same domain. And if you want to keep the original 4 shapes, you can hit also this checkbox, keep original shapes. If you hit apply, you will see a preview. Now if you like that preview and you want to work with that, you can hit the key E, hit escape, and you will see you have one shape. If you click on that, left bottom corner, you have one solid. Let us call this bioprop. As for the shaft, for a simulation, you might want to combine these also. You can just fuse these like we did before. Hit E, we have a fused shape. We have this impeller. I will ignore the rest, but the way you would do is the same, right? You have just for this case, if you select one, you will select both if you enable the shape selection, because the topmost shape is the compound. Okay, if you want to extract this, go to solid selection, box select both, hit extract, it will extract these two. So thanks for watching. I might create a tutorial in which we use SnappyXMesh to mesh such a geometry and get it done for simulation. So thank you for watching.